All right, everyone, we'll just go ahead and get started then. So our next talk will be by Carol Song from Purdue. She's the PI of another recently funded DIBS award at the same time as ours, which is about adding geospatial support to HubZero. And so I specifically invited her here because one of the, as I mentioned in my slides, is one of the points of these building blocks is they interact with one another. They build on top of each other and do bigger things than anyone can do. And hers in particular, especially with HubZero, has a potential benefit to Brown Dog in terms of encapsulating environments with the VMs that HubZero does, and possibly serving up extractors for Medici in the data access proxy. So with that, I'll just give it to Carol Song and let her talk about her project.
Thank you, Kenton, for the intro. So a few words about myself. Carol Song from Purdue, part of the Rosen Center for Advanced Computing, which is sort of analog to NCSA, but much, much smaller in size. And my colleague, Larry Beal, is in the audience. He's our geospatial data remote sensing expert, and he's co-PI on the project. So rather than starting listing out what the project is about, our goals, which I'll do later, I'd like to start by motivating with some of the examples, things that we have been working on. So as probably some of you are aware, HubZero is basically a web platform for scientific collaborations. And we've been working with the scientists of various domains on building modeling, data analysis, data collection tools on HubZero, as well as on other platforms. But HubZero, because it's hosted at Purdue and we have advantage of accessing the expertise. So a lot of my projects are on HubZero. So this one is one of those that, let me start my timer. So for this one, it combines modeling and data sharing in one. And it's part of a hub called Water Hub. And this particular tool is called SWOT Share. So SWOT model is a water soil assessment model for watershed scale hydrology investigations. And just a really quick look at this. So you can see highlighted areas. Those are hydrologic units. And highlighted areas indicate that people have run models on those areas already. And to create these input models, it takes, sometimes people tell me it takes a week, at least days to create these, because people do pull data from various places like USGS and use ArcGIS on their desktop and create these models. Then they're ready to run, and they want the supercomputers to run it. And in this case, we support people to run in 3 different modes. They can do normal simulation, they can do calibration, which is a process running through a large set of parameters. And they can also do sensitivity tests. So for different types of computational needs, on the back end, actually deploy to different type of systems. For example, we can do it on high throughput systems if we can really parallelize these things in large scale. If it needs MPI support, we send it to a traditional HPC cluster. So that's just a quick view of these. So these are models students have worked on in classes and researchers contributed. You can upload them and you can share with people you choose. And HubZero provides that framework that sets up groups, projects, allows you to specify who you want to share with. I'm going to show another project which integrates some of the wonderful technologies that we have now. In this particular case, it's a tool for sharing, accessing a large data sets produced by the AgMIC group. It's a large effort of comparing crop models. And so now people generated a lot of outputs in order to access the data that you want. There are so many parameters that if you look at these, this allows you to choose basically your model, your crop, the type that you want, and imagine navigating the Unix file systems, and people, after going down 3 levels, people get really confused. And so this way, we've integrated Globus Online into this, so users don't have to set up their own endpoints. And so, and then you can see there are multiple functions. And after they download data, they can create maps, and the maps can be interactive. Right now, it is not, and that's part of the reason we have to do this DIPS project. Let's see what else. And another variation of these type of capabilities is one of the drought information projects that we worked on for several years. And in this particular application, we wanted to show the impact of droughts on crops, based on crop yield data or planting data. I forgot, Larry.
This was the yields.
Yields. And so basically, we worked on the Indiana region, so we get drought maps from the U.S. Drought Monitor, periodically updated and cropped it to Indiana because that's the area we were focusing on. And then also have the yearly crop yield data and overlaid on top each other. And and then we can actually go in and show charts and stuff and see what's the impact of different drought levels on the acres of crops and types of crops. So all of these examples in the back end can be quite complicated. I was having a brief conversation with Anand. When you start dealing with GIS data, it's very complicated. There are layers, there are shapefiles, raster images, and you have processing needs, for example, aggregation and things like that. And for some of the GIS experts, yes, they can do it on their desktop, but they still have issues when they need to do large-scale computation-intensive tasks. And for a lot of people, they have data sets they want to share, they want to present the data in a visual way, and it turns out to be pretty challenging. And we've helped these people to create these tools, and we have a lot of software developers and web developers to do these things. Then we realized, really, this is a good opportunity for us to put this into the core HubZero. Let's see. And so just few quick words about HubZero. How many people have heard of it? How many people have used it? Okay. There's opportunities, right? So HubZero is really if you think of it, it's open source, it's freely available. You can download source code, build it yourself. If you're brave enough, you can download VM, run it on your machine. And it has a lot of functions to support scientific collaborations, like data sharing, project management, groups, wikis, all of those things that when you have a new project, the first thing you do is, I want to find a web server to run my project on. So there are a lot of features there. Now, most importantly, though, it combines both computation and data capabilities now with these collaborative features. So you can share tools just within your research group. When you're ready to share with the world, you can publish it. And there are these automated process for you to publish these tools. And basically, you upload your source, you build it. There is what we call workspace. I don't know. Basically, Linux desktop for you to build your tools, and then you follow these process. And when you push the button, it shows up on the website. I think that's one of the features that most people wanted when they start thinking of HubZero. Okay, and so yesterday during the discussion, some people commented, so HubZero does data too, maybe it was Canton. So this is a site some of the librarians or library people may be aware of, that Purdue is using HubZero for their institutional research repository, where people can publish both papers or reports, presentations, demos, videos, whatever you have, and data sets now. So this is one faculty that I worked with, and when you upload your data, you follow, again, an automated process. What you get from this is you automatically get a DOI attached to your data set. And your data set is not just raw bytes, it's actually this ball of things that you see there. You can put documentation, you can put, people can ask questions, so basically give you a platform to engage people. And Purdue, I think the library, or Purdue is one of the 3 data sites funding members. I don't know the exact correct way to say that, but so we have a process of giving out these DOIs. I think other people may have to pay a fee, but there is a process for doing that. Okay, so those are my driving examples. So let me go to my. So really, when we conceived the project, it was primarily wait, did it crash? I think it crashed. Maybe you didn't like the full screen. Let me do this. Advancing. Okay, there. Okay, so when we conceived the projects, our goal was really to make it easy, because we're sort of not tired of it. We'd like to see these projects, but we thought if we open this up for make it easy, a lot more people will do it on their own. So the goal is really anybody can create a tool that deals with geospatial data on HubZero. That's one of our goals, and anybody can share their data through HubZero. And so consistent with the HubZero philosophy, all of these things are meant to be for do-it-yourself style, so people can do it themselves, such as uploading data, even large data sets, uploading their CSV files and annotated and things like that. So that's our overarching goal. And specifically for the project itself, we really wanted to make data and tools seamless, to go from one thing to next. So traditionally, if you know about HubZero, it started with NanoHub, which was for nanotechnology simulations. Typically, those simulations, they take input parameters, you tweak some numbers, and then you say simulate, and it goes by calculate based on some formula, and then show you various output. It could be 3Ds, could be a plot, could be just numbers. So at that time, data was very small, and as time goes and people have larger and larger data sets, and people think of creative ways of using HubZero. So, and so we had, for a while, the development was, these are data kind of applications, and these are computation, and we really want to combine them. And geospatial data really forces us to do that. Also specifically, HubZero didn't have any native support for geospatial data, so that's a given. We want to put that in there. And also data services interfaces. We are interfacing with IRADs, we're interfacing with databases such as PostGIS, and also the geo rendering servers like GeoServer, ArcGIS, those type of things. And we also, HubZero didn't have a way, because it's architectured, that didn't have a built-in way of rendering maps and geospatial data. So those are the things that we wanted to put in there. And obviously, when this is all developed and done, it'll be part of HubZero releases. So anybody can download a tarball of source code or part of the VM. And funding, just real quickly, we're one of the 4 implementation awards and started last year, October. We're still early in the development. We're prototyping technologies. We have examples, we have pieces, and we're also working with the scientists on our team. We have 2 co-PIs. One is a hydrologist, and the other one is an ag economist. And they have large spatial data sets. Okay, so that's our team. We have, I think, 4 or 5 heavy-duty senior developers. We also have students. And then we have our domain experts. Larry is one of our experts. And right now, it's a relatively small team compared to other DIBs. And as I was telling people, this is a very focused software development project. And I'm really glad that NSF decided to fund us, even though it's primarily at Purdue. And we do have collaborators from various projects. David Tarboton on the HydroShare project, he's one of our supporters. And we are also partnering with the NEAS project. So it's not really, the capabilities won't be limited to just or science communities or some of those usual groups that you would think this would be useful, but can really be broad. We have partners in K-12 education. When they see some of the things we've done and they felt that they could really bring it to the classrooms, let the kids play with things. Okay, so those are, so I will skip this because most of people, these are some examples. So what I like to do, one thing I like to highlight is probably not many people knows the process how we put these tools into the hub. So so these tools are interactive, online, delivered through the web browser. Now, usually people ask, I have a tool, how do I get it into the hub? So there are 2 very straightforward ways to do it. If you already have an application that works with X11, you can just put it straight in. If it's Java, if it's Python, TK, a lot of those, any language you want. So as long as it works on your Linux workstation, you can put it in there. And there is a very straightforward process that you follow through the website, upload your code, you can test everything in your browser. And once you, there is a validation process that we use because some of these tools, all of them have access to the command called submit, which encapsulates all kinds of HPC, high throughput, cloud, resources or local clusters. So it's a very dangerous thing that we're opening that up to people. So we do want to, we're kind of like Apple. I guess some of the HubZero team, they really like Apple model, that they want to validate that you're not doing anything malicious. And but other than that, it's a very automated process. So you put it in and you press a button, and before you go live, you can test it with a group. You can add people to the group, and only those people can see the tools. They can pull it from SVN, build it on their in their own workspace. So that's and for the codes that don't have a graphical user interface, there is a library called Rapture with 2 P's, and so that you insert these calls, and basically what that lets you do is it plays your GUI widgets, the little elements, you know, a text field, a choice list, a display of 2D images, 3D plots, those things. And there's also a sort of a GUI builder to help you place those things, so you don't even need to know XML. So those are things that can wrap around your code and give it instantly a graphical user interface. A few words on the technical side, and I'm going to redo this picture. As I was working through it, I realized this is, I like to redo it. But basically, it's showing you sort of the big box is all HubZero. It encapsulates everything that would be implemented. So there are parts that's already done. Most of these parts are not structured as services right now, but we're working on those. So you would see familiar things like GDAL, the OSG Earth, OSG, that's not the computing OSG, that's the Open Scene Graph library. And so that part is really for the visualization of the geospatial data, map rendering, and all of that. And the Rapture toolkit, we're going to expand it with geospatial support. So basically, you can say, so for a tool developer, you really don't need to know a lot about geospatial processing, geospatial data. You can just put these elements in there saying, you know, I need a file. The user can upload a file in this field, in the type of file that it's required, and a lot of those other things underneath will be taken care of. And the other thing is in order to go from, to really tightly integrate tool and data, and what we're implementing is people can upload data directly to the hub, and then that data can be used by the tools that other people publish, or maybe your own. And then as you compute, as you generate output, those output can be published. So that gives you the entire workflow from uploading your local data combined with some other data from other databases, publicly available sources, and then do your computation and then get your output published, shared with either a group or just make it public. So so that's why you see that we're going to structure the data services as services. So any of the tools can use. Now, as linkage to Brown Dog, we started talking just recently. I guess there's not a lot of specifics yet, as we are learning about Brown Dog, trying to understand what it does, and then I think it's the same thing from the Brown Dog team. And from where I stand, I can see some obvious advantage for us to leverage Brown Dog capabilities, such as data conversion, because these tools will need to access data. Data is not always ready. And we're also going to support the ways because people want to do model coupling, which is a really hard thing to do, as I understand it. And data conversion is just one minor problem. But that, even at that level, I don't think we need to duplicate things if it's already available. So those are the things that I can see just straight out of the box we could work with the Brown Dog team. Now, the other way, whether some of these functionalities, especially tools that does maybe one thing really well, and maybe those are things that Brown Dog could leverage by calling through some sort of interface. And the way Rapture is designed, I can see the REST interface that Kenton was showing, basically the model of input, output, in your code, and that seemed to map really well. although I didn't write Rapture, so I need to ask Mike McLennan to see what he thinks. My suspicion is that he would say that's very doable. The only issue is priority. Right now, we're buried pretty deep trying to get our stuff done. Let's see what else I have. Some of those challenges, I think a lot of it on the application side is very similar to what I've been hearing in the last 2 days. And I think it's great also for me, for our team to hear these problems, and we can work that into our software as we do our design and continuously design and development. We have this very short cycle of iteration. Interfacing with other systems, that's definitely something that's on our mind. And HubZero already, I think, interfaces to Google Drive. And so if you create a project, I do that all the time. I have files, documents scattered in different places, and we always have trouble saying, okay, now this collaborative document, where is it? And so HubZero gives you a way to manage your project, everything in one place, and you can have your Google Drive also right there on your in your project space. Let's see what else I want to say. And like Kenton said, so one thing with this project is starting at the beginning, the NSFPD told us that you should start thinking about collaborations, and he's very flexible, saying, I'm not saying you have to sacrifice your project for these, but do think about it. And I think that's really good to think about collaborations at the beginning of the project rather than as an afterthought, in the year 3, 4 of your project. So that way, make us more conscious about where we can collaborate and have the conversation early. So I'm really appreciative being invited here. So right now, we're using IROD, so we're working with Regan's group. We've created some of the microservices to automatically extract data when you upload into the IRODs. IRODs is what we use underneath. And Globus, like I said, we've done custom solutions for integrating Globus Online. I realize we also have a proposal pending to integrate more with Globus Online. So if that's funded, great. If not, we're still working with the Globus team to use their services for transferring really large data, because everybody knows getting data into a web server isn't really fun, so we're trying to avoid that. And data one, that's one discussion we're having, because obviously for people using the geospatial features of HubZero, they would generate data, and if data one is one place they want to publish, that would be something we can consider supporting. And obviously, we're connected to Exceed, so we're collaborating there. Now, with other DIBs, Brown Dog is very close, both geographically and the type of work they're doing. So I think that's a really good thing to start talking about. Other SI2s, I know Shaowin and now Anand from the Cyber GIS project, and I would really like to know more about what they're doing, both on the technical level, also on the big picture level, to see whether we can have some more specific joined projects together. Let's see. I think that's it. So we're eventually gonna put demonstrations and installations on this new hub, My Geo Hub, which is dedicated to support various projects. So hub is, you can think of it as I call it mother hub. This type of hub is a mother hub. So different communities can have super groups. They have their own branding. They go in, they only see their own thing, but they can also leverage tools and data sets and other things that's hosted in the mothership. And we're also going to talk about the project and the progress we made in the late September, there is a HubZero annual conference in Indianapolis. Okay, I think that's it. Questions?